In this video, I'll be trying to provide the solution to the 2025 first semester physics test question for engineering students. The question here, question 1B, says the frequency n of vibrations of uniform string of length and stretched with a force F is given by n equal to p over 2l root f over m, where p is the number of segments of the vibrating string and m is a constant of the string. What are the dimensions of m? That's the question. Right, so looking at this, you see that they give us an L here. You have P over 2L here. So you have an L here, but L was not defined in the question. So the first thing you have to observe is that the question, something is missing, right? So what it said, the frequency n of vibrations of uniform string of length should be L, right? So of length L, comma, so it should have been there. Then you now continue by saying and stretched, okay, and stretched with a force F equal to this. So that's it. So notice that the L is missing, right? So L represents length. That's the first thing for you to note. So how does this concern our solving and what do we do? So after noting this, the next thing you have to do is, let's take down solution. Let's take down solution. For my solution here, I'm going to list out the parameters, right? So solution, let's list out given parameters. So given, all right, what's the first thing you're given there? From the formula here, the first you have this n, right? So given number 1, n, and n is equal to, what does n represent again? They said the frequency n of vibrations. So n is equal to what there? Frequency. For frequency, what's your dimension? Now let's get a dimension for frequency. I'll put that in a bracket. For frequency, don't forget that frequency f is equal to 1 all over period, and period is t. So the dimension of frequency is equal to t to the power minus 1. So I have t to the power minus 1 as the dimension of that. So it becomes t to the power minus 1. That's the dimension for frequency. What else do I have in that question? Then number 2. Number 2 says, they said uniform string of length L. Right, number 2, I'm giving length. So L is equal to length. For length, what's your unit there? Or what's the dimension for length? The dimension for length is capital L. Okay. What next do I have again? They said stretch with a force F. Alright, let's get for force. Number 3. F, capital F is equal to force. It represents force. And for force, the dimension for force is mLt to the power minus 2. Now, mind you, we've already discussed all of these concepts of dimensioning in our previous class. So if you missed out our previous class on dimensioning, I'll leave a link, right, that explains the concept of dimensioning from scratch in the video description. Okay, so check video description. You see a link to the class on dimensioning. Okay. All right. So what's next there? They said it's given by this. Say where P is the number of segments. So P is equal to what there? Number 4. Excuse me. Number 4 is equal to what of number 4? To us P. P is equal to what there? Number of segments. The question becomes, for number of segments as said in the question, right? What is the dimension of number of segments? Now, let me tell you something. If you look at number of segments, if they ask you what is the number of segments, you probably say something like, if you have 3 segments, you just say 3. If there are 7 segments, you just say 7, right? It does not come with an SI unit. That's like the concept, right? It's a dimensionless quantity. So P only represents a particular number. What number? The number of segments, right? It could be 4, it could be 7, it could be 10, depending on the available segments. But then it comes with no SI unit. So we can say this word there, dimensionless. You should take note of this. Dimensionless. That means it's what? It has what? No dimension. It's just a number. All right, what else are we missing here? What's not here? They said m is the constant of the string. Okay, let me see m. So number 5, you have m is equal to, they said, a constant of the spring. M is a constant of the spring. Constant of spring. Constant of spring. What is the dimension? Unknown. Just call it question mark there. It's unknown. So I have these 5 parameters here. Right, we have to find the dimension of m. That's it. All right, and possibly would find the dimension of m, and they will possibly predict what parameter it represents. Okay. Now, in finding the dimension of n as required in this question, there are 2 ways to go about it. All right, I will show you 2 different ways of finding the dimension for m. Okay. First things first, let's write out the formula given. The formula given is that n is equal to P all over 2L root, root F all over M. This is the first thing there, all right? And I want to make M to be subject of the formula. Now, for us to do that, the first thing we want to do is to eliminate the constants there, right? The things that do not really have dimensions, we want to take them off. So in this formula, what and what does not have dimension? Note that the first one that does not have dimension there is P, right? Because it represents a number. So in essence, I'll replace P here. I'll just take this one off and just put 1 here because it has no dimension. Also 2 here does not have any dimension. I'll just put 1 there. So with this, we'll have that n is equal to, this P is replaced by 1 all over. In this case, I have 1 times L. Replace 2 by 1 becomes 1 times L. The value becomes L. Then root, so square root of F over M. So I have F all over M. All right, so we have this one here. So this is what it would look like if there is no dimensionless quantity. That means every parameter you see in this particular formula here all have a dimension. So that's your first task. Take off the dimensionless quantity and just work with the ones that have dimensions. All right, so we have this one here. At this point now, we want to make m to be subject of the formula. So say make m subject of the formula. So what's my equation again? I have that n is equal to 1 all over L square root of F over M. You want to make M to be subject of the formula. Our first task would be you have to move L here, right? It's mathematically correct. If L goes up there, you now have something that looks like NL. It's equal to square root of F over M. This is correct, okay? Because this is 1 over L. So the concept is simply N equal to 1 over L. So L goes up here. You have NL is equal to 1. So this one now multiplies what you have here. So 1 times root F over M gives you root F over M. That's the simple mathematical idea here. All right. All right, let's proceed with this. So from this, what do you have next? From here, again, we want to make M to be subject of the formula. That means we'll have to square both sides. I'll say square both sides. If I do that, you have NL squared is equal to root F over M. This all squared. All right, square both sides. This becomes, for here you have N squared L squared is equal to, for the right hand side, square root will cancel square. You're having F all over M. You have this. So how do I make M to be subject of the formula here? Now you might want to say cross multiply and all that. Well, that works. Say cross multiply. So this is all over this, right? If I cross multiply M to this, then F to this, it becomes M multiplied by N squared L squared is equal to F times 1 is F. To get the value of M, I'll divide this and also divide this by divide this by n squared L squared, divide this by n squared L squared. This will cancel this. So we'll have that m is equal to f all over n squared L squared. All right, so we are here. With this now, we've made m to be subject of the formula. Of course, after eliminating the dimensionless quantities, which was 2 and then p, the number of segments. At this point, we'll now say substituting dimensions. Let's substitute. So substituting dimensions. All right. So we'll have that m. If I substitute dimensions, we'll now have that m. So I'll just take this here. Said m is equal to our formula said f. All right. For f, what's the dimension for f? If you go back to this to see for f, your dimension for f is mlt to the power minus 2. All right. Let's put the dimension of f there, mlt to the power minus 2. So this is ml to the power minus 2. That's f all over. Next up here becomes n squared L squared. For n, what's your dimension for n? For n, the dimension, as you can see here, is t to the power minus 1. That's it. Okay. So let's impute that value there. T to the power minus 1. Let's impute the value there. So it becomes n, which is t to the power minus 1. They said n squared, so I'll square this. So after n squared, the next thing there, let's see. After n squared, the last thing there is L squared. For L, the dimension is TL. So it comes here L squared. So we have this. Alright. Alright, so our task will now be to simplify this. Simplifying this, we'll have that m is equal to, this becomes mlt to the power minus 2 all over. Working on denominator, we'll have that 2 multiplies this minus 1 here. That becomes t to the power 2 times minus 1 is minus 2, then L squared. So we have this. Alright, let's simplify this. In simplifying this, right, your task would be this. M is equal to, separate the numerator from denominator. My numerator here is mlt to the power minus 2 multiplied by, so if I take this one off from here, which is numerator, which I've done, I'll be left with 1 all over all of denominator there, which is 1 all over t to the power minus 2 L squared. All right, so get this simple task. So shift out the numerator, you'd have this. So what next here? At this point, we'll have that m would be equal to mlt to the power minus 2 times, we'll take this one after the other. That means it becomes 1 all over the first parameter here, t to the power minus 2 times 1 all over the second parameter there, which is what there? L squared. All right, just follow my step. Now at this point, what next here? The next thing we'll do here is that this becomes m, it's equal to, we have this as mlt to the power minus 2 multiplied by, now don't forget that if you have a to the power, or let's say we have 1 over a, in index, this is in as a fraction, in index form this becomes a to the power minus 1. Okay, if you have this as 1 all over a, let's say to the power 3, this becomes a to the power minus whatever thing you have here, which is 3. Okay, the concept here is very simple. If I have 1 all over, I will introduce a minus or a negative to the power. So for this one here, observe I have 1 all over, so introduce a negative to the power. It becomes t2. To eliminate this 1 here, I'll introduce a negative, so it becomes negative of the power. The current power here is minus 2, so it becomes minus of minus 2. This times, again I'll pick up L, so times L. I'm having 1 all over, so it becomes, introduce a negative, so it becomes negative of the power you have here, which is 2. So negative of 2. So I have this. So this is how you work out this question. Alright, so let's simplify this. This will be equal to, and write this up. equal to, or let's say m would be equal to. Now in simplifying this, we could choose to work with this t first. Let's work with this t first. Okay, so I would simply write out what I have here, which is mlt to power minus 2. That's mlt to power minus 2 multiplied by, next thing I have here is, let's simplify this. So it becomes t into minus minus gives you what there? Plus. So it becomes t to plus 2, or simply t squared, t raised to power 2 or plus 2, or t squared, same thing. Then finally times, the last thing I have there is l to power minus 2 times l to power minus 2. So I have this. Alright, we are almost done. From here, m would be equal to, in arranging this, don't forget that the system of dimension we're using here. So in working on this, don't forget that the system of dimension we're using here is called the MLT system. MLT, system of dimensioning, which means I'll take mass first, and then length, and then time. Alright, let's arrange them in terms of mass first, and then length, and then time. Starting with mass, I have this one here, m, so it becomes m. Taking length, we have l, so it becomes l. We also have another length here, so say times l to power minus 2. Take your time, we're done with l. Let's take t's. The first t is this, which is times t to power minus 2. Then this other t here, times t to power 2. So from here, m would be equal to, this becomes m into l. The power here is 1. Okay, when you're multiplying bases, you add up their powers. So it becomes 1 plus minus 2. If you punch 1 plus minus 2, you have minus 1. So it becomes l to power minus 1. They will now have t into, again, two bases t and t, two same base t and t. If you multiply them, you add 2. When you multiply them, your simple task is to add up their powers. So it becomes minus 2 plus 2. Right? If you punch minus 2 plus 2, you have that as what? The 0. So you have this as your answer. Let's proceed with this. From here, this would be equal to m l to power minus 1. From the zeroth law of indices, it says that anything raised to power 0 is equal to what? 1, except 0. So t to the power 0 gives you what there? 1. So I have this. That means the dimension for m would be equal to capital M and then L to power minus 1 times 1 gives you this. So the dimension for m is actually ml to power minus 1. What's m? M, we said, it's equal to mass, that's m, and then L is equal to what there? Length, in the concept of dimensioning. So you have ml to power minus 1. It simply means mass divide, okay, before then, let me put it this way. Before then, ml to power minus 1 simply means m times this one here is simply 1 all over L, and that's equal to m over L. M is mass, L is length. So just in case you're asked to find what parameter it represents, the answer here is mass per unit length. Okay, so m is equal to mass over length. In physics, it's called mass per unit length. That's what m represents. And the dimension as required is ml to power minus 1. So basically, this is the answer to that question. Now, I said I was going to show you two ways of solving this question. So this is the first method. Let me show you the second method of solving this question. Okay. Alright, so let's look at method 2. Alright, so solution to this same question. Look at a second method of solving this, and then you choose which is best for you. Alright, so method 2, let me call this method 2. Now, method 2, for this, of course, you list out your parameters and all of that, okay? And we have that n, it's equal to, we're given n is equal to p all over 2l into the square root of f over m. We have this. So how do we solve this using our second method? Um, Again, the first thing we have to do is to eliminate the dimensionless quantities. That's p becomes 1 and 2 becomes 1. We'll take them off and replace them with 1, and that's equal to 1 all over L square root of f all over m. We have this, okay? So from here we'll have that n is equal to 1 all over L root f all over m. Now what do I do here? My simple task is to impute the dimensions at this point. So I'll say substituting, right? Substituting dimensions. Remember that in the first task, or in method 1, we had to make m to be subject of the formula first. In method 2, we can just proceed to substitute dimensions straight up, okay? And if you do that, we'll have that n, for n, which is the frequency, we said the dimension is simply t to the power minus 1. That's n is equal to 1 all over. Next you have there's L. For L, we said the dimension is capital L, that's length, into the square root of, we have F. We said F is what there? Force. For force, what's your dimension? It's mlt to the power minus 2 all over. Finally, what you have there's m. Okay. For m, what's the dimension? It's unknown. Right, so since it's unknown, we could leave it as m, or we could express it in terms of dimensions. Right, you could leave this as m. Since you don't know the dimension, you could leave this as m, or better still, express it in terms of dimensions. Whichever way, you have the same answer. To make it easier for ourselves, we say let's leave this as a small m, since we don't know the dimension. Okay, so we have this thing here. All right, so for m, what we do is this: we say let the dimension of m, let the dimension of m be equal to, now I know it will be in the form mlt, that's m, l, and t, but I don't know what the powers are. So I'll call this m to the power a, l to the power b, t to the power c, right? Since they are known, so this is still the mlt, and then the powers are unknown. So this becomes m to the power a, L to power B, T to power C. So I have this. So basically, I would have this concept here. Now my task here is to solve this. And in solving this, one of the first things I want to show you is that if I have, let's say P is equal to 2 over Q, it is correct to say these two would come together to give you P times Q is PQ equal to 2. This is correct mathematically. Now, why am I showing this? I'm showing this because we can use this concept in the given question here. That's in saying that this L can come up here, all right, and that becomes T to the power minus 1 times L. Now, don't forget it's an MLT system, so L comes first. So I'll take L first. Okay, so this L and then T to the power minus 1 is equal to, I'm left with square root, so it's equal to the square root of m L T to the power minus 2 all over m to the power a, L to the power b, T to the power c. I have this. Alright, so I'm here. Don't forget I want to get this particular value. Alright, so all I have to do is square both sides. Square both sides. Square both sides. If I square both sides, what do I have there? This becomes L to the power minus 1. So I have L to the power minus 1 all squared will be equal to the square root of, what I have here is ml to the power minus 2, ml to the power minus 2 all over m to the power a, l to the power b, t to the power c. I have this. Alright, at this point let's square both sides, so I also square this. Alright, from here, this becomes, if I square this, it becomes L squared. So I have L squared t to the power minus 1 times 2 gives you minus 2. It's equal to, for the right hand side, the square root cancels square. I'm left with ml t to the power minus 2. This all over m to the power a. So this all over m to the power a, l to the power b, t to the power c. Now remember what I told you earlier about having terms like this, where I said these two can also switch position. So if I have some, let's say something like a, it's equal to 2 over b, it is mathematically correct for this to come here, that's a goes here and b goes up. So I'm having something like b is equal to 2 over a. This is mathematically correct. All right. So with that being said, let's make this one here go up here. So this one goes up here, and then this value comes down here. So I'll have m to the power a, l to the power b, t to the power c. It's equal to, this gives you m l t to the power minus 2. This all divided by, so this all divided by the L squared t to the power minus 2 comes down here, becomes L squared t to the power minus 2. So I have this. All right, this is mathematically correct. So from here, what happens here, you can see that would have m to the power a, so m to the power a, l to the power b, t to the power c. It's equal to, from here, l here 1, L here, this gives you L, right? It's L squared, it cancels 1. Here I have t to the power minus 2. I have t to the power minus 2. It's mathematically correct for me to say this will cancel this because they're literally the same thing. You have t to the power minus 2 dividing t to the power minus 2. They're the same thing. Just like when you have a over a, we say a cancels a to give you what there? 1. So if you have t to the power minus 2 divided by t to the power minus 2, they are exactly the same thing with the same sign. So they will cancel out. Alright, so this one cancels out here. And you have here as 1 and 1. So what are you left with here? I'm left for numerator, you have m times 1 times 1. And that gives you m all over. For denominator, you have L times 1. And that gives you L. And this is equal to this L becomes L to the power minus 1 in index form. Okay. Now, with this, we can say that m to the power a, L to the power b, t to the power c, it's equal to m L to the power minus 1. So from here, what's the value of a, b, and c? A is equal to the power attached to m here, which you can see is 1. So a is 1. B is equal to the power attached to L here, which you can see is what there? Minus 1. And then C is equal to the power attached to T. Observe that there's no T on the right hand side, so it becomes what there? 0. So hence we can say that this is equal to the dimension of M, dimension of M, it's equal to, you have M to the power A, which is capital M to the power A. What's the value of A? Check. A is 1, so M to the power 1. L to the power B. What's the value of B? Minus 1. So B here is minus 1. And then T to the power. What's the value of C here? So it's C. The value of C is 0. So this into 0. And that's simply equal to M L to the power minus 1. T to the power 0 will give you what there? 1. So 1 times this gives you itself. Again, we still arrive at ml to the power minus 1, which we said is mass per unit length. Okay, so basically this is how you solve this question. Alright guys, so if you enjoyed this video as usual, don't forget to hit the like button. Alright, like this video. Alright, leave a comment. If you enjoyed the video, leave a comment. Say thank you. If you have a question, leave the question in the comment section and I'll give you a reply. Don't forget to also subscribe. If it's your first time here or you're yet to subscribe, please do well to subscribe to this channel and hit the bell icon. Select all so that you get notified whenever we upload a new content. Then finally, share this video to your friends so that they can also learn. Do also visit my website www.jonahemmanuel.com/courses to check out the available courses, or www.jonahemmanuel.com/books to see any of the available books. Register an account to the website and then proceed to get any of the available courses or books. Thank you and see you in our next class.